So today I'm talking about one of my work to study social coordination in human groups in an emergency. And the title is Individual and Collective Learning in Human Groups Facing a Danger. So I'm happy to take any question during the talk. So if you want to clarify, for example, my studying setting or the terminology I use, just let me know. I'd be happy to answer the question even during the talk, okay? So let me start. So I got actually my PhD, not in School of Computer Science or not in HCI. I got a PhD in sociology and now work at HCII, the School of Computer Science. So actually my career itself is like a computational social science. I thrive in the two disciplines as a computational social scientist to study the inter-individual dynamics of social dilemmas and collective action problems in human networks. So we humans often face challenge in collective action when individual and group benefit are not aligned. So in such a situation, individuals may see no optimal way to act. So since I found the fundamental problem for society, so even for each individual try to do the best for themselves, this does not always result in the best outcome for society. Okay, so that's interesting. So that means that even if each individual do the best effort for themselves, it doesn't not mean we have a good society. I know it's a bit crazy argument, but it's really true. So since I found the fundamental problem for society, I've been obsessed with it, especially how such a collective context, so such a collective challenge emerged from the web of social interaction in various social contexts, such as resource sharing, emergency evacuation, and division of labor. And based on the theoretical and empirical background, I've also explored the potential of machine intelligence for intervening in human networks to facilitate cooperation and coordination. So the reason why I'm especially interested in the technical intervention, like the last one, is that I was actually the mechanical engineer before I got a PhD of sociology. So actually I worked for the Sony Corporation for 8 years as an engineer to develop actual robots, then to see how robots interact with a real human. Then I quit the Sony there with various reasons. If you are interested in that, I'm happy to answer in person. Then I started to explore the social aspect of the human interaction, then how technology actually works to improve the web of social interaction among human groups. So this is, for me, this is very natural direction for me, but it's actually the unique venue to combine between the sociological aspect with technological intervention. But today, from the rest of my work, I'm talking about a series of social experiments to examine social coordination in an emergency today. And this study does not include about, maybe interesting in the future work, but this is purely the result of human interaction within some systems. So I realized the importance of social coordination when I actually experienced the social confusion caused by a big earthquake in Japan in 2011. So on occasion of emergency like this, social coordination is potentially more important than usual. So in daily life, yes, the social coordination sometimes is inefficient. You might be complaining about, hey, how like S3D structure is really inefficient to improve our study. But such a daily life, it's okay, not so important, right? But in the emergency, this type of inefficiency in the social coordination is really the life or death problem. So with a natural disaster approaching, the prompt and reliable information exchange would be essential for people's safety. But on the same time, coordination is more difficult than usual. In reality, as you may know, because you already studied that fake news spreading or the polarization, many network phenomena, such as spreading false rumors and network disintegration, often prevent efficient coordination, like fake news turmoil that now happen almost every day, unfortunately. So this is an example of false rumor tweet after the earthquake in Tokyo. So please spread to those people who live close to the east shore of Tokyo Bay. Due to the explosion of oil tanks, harmful chemical materials will fall with rain soon. Bring your umbrella and raincoat with you to protect your skin from the dangerous rain. So I translated Japanese to the English version, but the message said, actually this, the explosion of oil tanks is true. This happened after the big earthquake hit in the North Shore of Japan. But later, it's no scientific background. It's not totally false. And actually, after this tweet come up, I think in just 5 minutes after this tweet come up, some people correct this tweet. There is no scientific basis. It's totally false. Then this happened. So this warnings quickly turned out to be false with no scientific basis, but many people spread the rumor via Twitter. The right figure, which is not from my paper, but shows a snapshot of retweet network about this dangerous rain tweet. And the false warnings lasted a full day. So this is like a follower-following network at this time. And the red node indicated the account to spread this false rumor. And if you have a good eye, you might see some blue node. Can't you? Yeah. This blue node mentioned about this account correcting, spreading the correct tweet. This is no, this is false. This is scientific. But even after you can see the time, 4 hours later, still people spreading more on the false rumor tweet. And actually, as I told you, I was in Tokyo at the moment. So that means that probably my Twitter account is one of them, but I don't want to say which color I have. Social media data like this offers great insight, you probably know that, about such massive social phenomena. But it also has a limitation, I think. For example, when I analyze this type of the Twitter data at the moment, I found it's really difficult to trace information flow directly from the recorded data. So that means we needed to have some assumption to extract the information flow from the social media data like Twitter. Also, such social media data contained what people say, but doesn't contain what they actually did. So it's really hard to the discrepancy between their word and their actions. So I do not deny at all about this type of the analysis, but many people already work on this big data analysis. So I would like to do the different things. I decided to use this experimental scheme to supplement observation study like Twitter data analysis. In the experimental scheme, I recruited real human participants. It's not computational simulation. It's the human subject experiment. So I recruited real human participants from online labor market. For example, you might know like Amazon Mechanical Turk or Prolific, and let them work together to do a social coordination task in an artificial network. So this network is artificial. It's not their own like naturally developed networks. Then I started developing the experiment system to examine why sometimes social coordination is hard in the emergency. But I found there was not a good experimental model to examine social coordination for that type of the work. So I invented a new coordination game. It's called evacuation game. So let me explain the game paradigms. So this game is economic game. So that means that I gave the actual money to the player. So that means the human participant based on their performance. And at the beginning of the game, each player receives $2 plus alpha. So I will explain about what is alpha, but basically they can earn $2 and more. And when nothing happened in the game, players earn the entire bonus. So if you were the player, you could need to do nothing to earn the $2. Okay, so that means that at the moment, I think that 2012, I forgot the time, but at the moment, my task, I think, is the most economically efficient task in the Amazon Mechanical Turk. Okay, so you don't need nothing, just join the game and just wait, then you earn the $2 and more. But life is not that easy. If a disaster strikes you, the disaster here is like a symbolic disaster. So the disaster strikes you, when you are involved in the disaster, then you lose entire bonus. You earn 0 bonus, okay? So in the game, I gave you a behavior option, that's evacuation. So you can evacuate from a possible disaster by spending $1 from the endowment. So if you want to select to evacuate from a possible disaster, you needed to spend $1 from 2 immediately. Okay, that's the structure. And I think this structure is mimicking the actual behavior decision making when you're facing some uncertainty, like a disaster approaching. So evacuated subjects are not involved in disaster. Even when a disaster strikes, you still earn $1 and more. Okay. So the game point is simple: to figure out whether a disaster would strike and select a correct behavior. If a disaster is going to strike, you should evacuate before it happens. Otherwise, you should stay on site to the end because you have to pay cost to evacuation. So like a telephone game you might play when you are a child, players are allowed to communicate with local neighbors in a network. So as I told you, I developed artificial network and gave them. Then I place each player to a certain point. Here is indicated the dot in a network. So here is 40 players in a network. And they can communicate only with their local neighbors. And you might realize all the players have 4 neighbors in this network, if you count it. So it's intention. And I will tell you why later, but in this network, I created a very specific network configuration that all players have 4 neighbors. Then they can communicate. I also tell you about how they communicate with their neighbors. But I randomly select one player, and here is this orange guy, and he or she get the true information just after the game started. If a disaster is going to strike, the player get the information about, hey, a disaster is going to strike. And if there's no disaster, the player get the information about there is no disaster. So if you spread accurate information originating from the informant, here is the orange guy, you can correctly choose a correct action. You don't need to rely on a random guess with this interpersonal communication in this game. Does it make sense? Okay. By the way, if you are selected as non-informant, so most of the majority of the players, you get this message: a disaster may or may not strike. So here is a game view for the player. There are a couple of things going on. First, player can see only the local situation like this. The central node is you. You get now $2. And you have 4 neighbors. Then I will show you how you can see the signaling. And also you have 3 buttons, very simple game. 2 buttons for communication, 1 button is for evacuation. Then you can click anytime this communication button. Then I will show you that when, please wait a little bit more. Yeah, one thing is not good. So when you click save for danger button, your node turn your change color blue or red, then your local neighbor see your node color. Like you can also observe your neighbor's color. Then so here is $1.5, but actual game is $1. You can click anytime you want for the communication button, no cost. Okay. But once you click exit, you leave from the social network and you cannot join the coordination at all. And the exit button, you can click only once for the exit button. So that means that your choice is to click exit or not. Then unfortunately, this game, a disaster is going to strike, and this player have nothing. You can see that. So, so that's danger, and nobody, including an informant, when it happened if a disaster strike. Okay, even for the informant, they don't know when it happened if the session of the disaster is going to strike. Yep.
Quick question. Do people know that you have access to the data?
Sorry?
Can people know that, can your friends know you have access to the data?
Access of the game, but it doesn't.
Like you click exit.
Oh, exit. Oh, okay, exit. Yes. No. So that means that like online communication, you cannot observe the behavior of your friend online, but you can guess. So as I told you, once people evacuate, they cannot come back to the coordination. They cannot click like safe or danger buttons. So that means that if you can guess, oh, this player do not communicate, send a signal for a long time, they might evacuate. Like you see that, oh, this player is offline a long time. That might be evacuate, right? Okay. But you cannot get actual signals of behavior. Okay. Yeah.
Is it possible that those who don't exit kind of signal by clicking, alternating the buttons between
Safe and danger?
safe and, yeah.
Yeah, it's possible. Anyway, it's fine. So that means that I do not like force them to do like a certain behavior. Of course, I just give the structure, right? Just paradigm. Then I do not ask them how they play. So that's fine. For example, some player might be just checking like a clicking like a danger and safe button alternatingly. There's no economical explanation, but doing, then just making confusing about the situation. That's fine.
I was thinking more kind of like, Morse code.
Uh-huh.
If you can.
Oh, yeah, it's possible if your neighbor could understand the neighbors sending the Morse code.
It doesn't have to be as elaborate as a Morse code, but maybe,
Yeah, for example, like if you have some idea like, hey, maybe people might be react more promptly if I sending a safe signal first, then changing the warnings. If you have such an idea, yeah, you can apply. There is no restriction. Okay. So this table summarizes the player's payoff structure. So then I told you about what is alpha here. So alpha is here is that if not only you earn the money based on your behavior, but also you can earn the money based on other players' behavior. So that means that if other players select the correct decision, okay, so if not no disaster, they should stay. If a disaster, they should evacuate. Then you can earn more money by the number of the players who select the correct action. Okay, that incentivizes the people who can share the accurate information. All right, here is I recruited the people from Amazon Mechanical Turk, so that means they are strangers with each other. So you might argue about, hey, they have no incentive to share the accurate information in this game. But I actually gave the economic incentive for them to share the accurate information to that. Okay, and here you can say, if you stay, if not disaster does not happen, you earn the maximum. But you can also risk to everything, right? And so that means that evacuate is low risk, low return option, and stay is high risk, high return option. And in the introduction, I tell them is a disaster may or may not strike. So this is kind of like a, hey, situation, disaster happened at 50-50, and it's actually happened at 50-50. So I ran the experiment. I forgot number, like more than 100 sessions. Half of the session have a disaster, and half of the session does not have a disaster. Okay. All right. Then I would like to ask you about what's going on in the experiment. This is one of the actual sessions. I will show you the animation, what's going on. In the animation, if the node change color from blue and red, that means that they sending like danger and safe signals. Oh, by the way, I forgot to mention that the signals disappear like disappear in 5 seconds. So that means that if you want to keep like sending like here this situation is danger, you should stay. So that you shouldn't evacuate. You should stay and keep sending the signals. All right. Okay. And this player got a disaster is going to strike, and in that animation, I will show the evacuated player with bold node like this. But as I told you, in the actual game, player could not realize this player is evacuated or not. Okay, so here is 40 players. Please use your knowledge as a PhD student to find out how many players evacuate in 75 seconds. So in this session, a disaster is going to strike. And these players get the information just after the game start. And this player would actually in the game send warnings correctly from 10 seconds to 30 seconds, then evacuate. So that means that this player is good. Actually, keep sending warnings 20 seconds, then evacuate it successfully. Okay, including this informant. So that means only you already know the one player evacuated. How many players evacuate successfully before the disaster happened in 75 seconds? So you already learn about some social influence theory, or you already analyze like a false tweet or the polarization things, Twitter data, blah, blah, blah. Okay, please use your knowledge. All right, do you have number? So here is 40.
What's the network structure?
This network structure, random regular. So that means that, as I told you, here is a random network, and all the players actually have 4 neighbors. You can count like 1, 2, 3, 4. Every player has 4 connections. All right. So you please raise your hand if you think 0, actually 1 to 10 players evacuate. Oh, 10 to 20. Okay, 20 to 30. Okay, 30 to 40. Oh, okay. So the director has the most optimistic view for the people's ability of the social coordination. Let's see what's going on for this specific session. All right. So this is a real-time animation. Now the informant sending the warnings, then you can see the information spreading through the network. So this is, I think, fascinating. The experiment clearly shows the information pathway, and some players evacuated seeing the warnings. And here is now the warning spreading in this area and this area too. But you can see, for example, these players sending the warnings, but do not decide to evacuate. Disaster is actually going to strike almost 20 seconds, but still people chat.
Do they know how long?
No.
Is information given only to one person?
Yeah, give one person, yes. Oh, yeah, that's a good point. So I will be able to explain the detail about that. That's it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9 of 40 players evacuated successfully, even if the informant sending correctly, you can see, and warning spread a little bit, but surprisingly, false reassurance message. So false safe message emerge naturally from that. And if you see my this pale structure, if you know some econometrics of this one, there's no economic incentives share the false information. Okay. Then you might say, hey, Hiro, you might show some shocking result, like the outlier result. It typically happens some like flashing talks. That means the people just choose a specific session to surprise people, right? No. Here is the aggregated result of the dozens of sessions per treatment. In this study, I manipulated the network size and topology. So here is 10 node, 20 node, 40 node, 60 node. So I show you the 40 node and the random regular network. So that means this green line. average. Then the percentage of the evacuated fraction is the rate of the evacuated people, 20%. Yes. So that means that 20% by 40, so that means averagely roughly the 8 people evacuated on average, very small. And as I mentioned that I putting only one informant to the network. So one point is that I didn't mention to the player, you have only one informant. You have some informant, and they know, some people know the truth, but maybe the informant, so the single informant, might be less obligation if they say, hey, maybe there is some informant, and maybe I don't necessarily to share like responsible for all the players. Yeah.
So in case of danger, if one of the participants got the information, started spreading it,
yeah,
that means that for others, they see only one, like at first they see only one person among 3 or among 4 sharing danger signal, and if they rely on consensus as the measure of accuracy of information,
that's
they
right.
might kind of disregard it as like false positive.
Yeah. So I'm answering a little bit, give it a nuance. So for this experiment, I also give if the I also give the information on who is the informant. So that means that if you have 4 neighbors, then if one of you, one of the neighbor are informants, so that getting information indicated with I. So that means that they can weight the information from the informant. And actually they do a little bit, but you are true. That means that they evaluated the signal, not only one signal, they evaluated the fraction of signals. But the question is, why so many false safe signals spreading? That's why they need it, right? Hey, here are the 2 players are safe signals, 1 player is dangerous signals, then I count it. Then maybe the safe, only 1 player. But for example, if you run the simulation, computer simulation for this is not difficult problem because there is no dilemma, right? Here is 1 people. Then if we program the agent to just pass the signal, if you get, then they can share the correct information with the machine. The problem is that people chat even without they have information. Okay.
I have a quick question.
Yeah.
So you also mentioned there were some sessions that the ground truth is no disaster.
Yeah.
So here you listed the evacuation factor.
Yeah.
So what about the evacuation factor for those?
Yeah. So here I told you, I show the half of the session. I told you the half of the session having a disaster, half of the session does not have this result as the result of the half of the session. The opposite. So that means that if the evacuation diffusion, when a disaster does not strike, is that the curve go a little bit down, but similar. Okay, so that means that people that when the disaster doesn't happen, social networks works, the people works well. They stay together. Okay, successfully when a disaster doesn't strike. But they are biased towards the same way, even when a disaster going to strike. Do you understand? So this curve is a little bit go up. A little bit. Actually, 6 nodes almost run the same thing. But a little bit like the slope is more few. So that means that the line is like this. So that means that most of them successfully stay. But here is the thing, disaster strike, the evacuation means the wrong decision. So the evacuation means the success decision, they should do more. And here is I control the network topology in 2 ways. So in one way is that random regular network and ring-rat networks. So you might know why I choose this one, is that this is good network structure to control the network topology because both networks have the same number of the nodes, same number of the connections, so that means the same number of the edges, and same local situation. All players have 4 neighbors, 4 connections, you can see. But global topology totally different. So here is a random regular network, is that you can pass the information very quickly to the other side of the networks, maybe 2 or 3 steps. But you need the multiple steps, like 5 or 6 steps to spread the information from the other side. But you can see here is a ring-rat network. There are a lot of triangles. There is almost no triangles. Then famous study in some experiment studies show like if the information spread like a disease, this network should facilitate the spreading of information better than this one, right? Because this network is actually passing information very quickly to everyone compared to this. But actually, when we want to spread something like a behavior, actually this ring rat network works better than this. Why?
Trust.
Yeah, trust and actually the multiple touch point. So that means, yeah.
Yeah, the actual message of danger, it didn't reach too far, right?
Yeah.
In your animation,
Yeah.
it's just like a local
Yeah.
network.
Yeah.
Yeah.
Yeah. So because, for example, like you are true, like if I get only one warnings, then I have 2 or 3 safe signals, then I stop sharing the information. But this network, if you 1 people or 2 people for the shared warnings, immediately other people see the 2 warnings at the same time. So this network transitivity helps to spread the behavior. Okay, so this is not only my find. Actually, the orange lines go above than the green. So that means that here is in particular the evacuation diffusion happen with complex quotation. But I wanted to pay attention. I want you to pay attention more on the result to another treatment that I haven't presented yet. That is independent condition. So independent condition, there's no network like this. So it's crazy. That means that each people have no connection, just decided to evacuate or not, just on their idea, random guess, right? Hey, yeah, maybe this situation danger, so I should evacuate. Because even if you click, you can, actually they can clicking safer danger, but yeah, actually they do, surprisingly. The signal doesn't go nowhere, but the point is, this independent quotient of the gray line go above of the colored line. So that means that people in the independent quotient decide better than the people who are in a network and access the true information through the interpersonal communication. Yeah, it's crazy, but it's true. And you can see here is even for the gray line go to like above 45%. So that means in the introduction, I told them like a disaster may or may not strike. So look like 50-50 chance. So that 45% of the people to evacuate is kind of reflect to the probability of the disaster happen. So that's good. The crazy thing is that the people who are network condition does not go above the gray line. So the crazy thing is that the colored line does not go above the gray line. So that's, I think, the strong advantage using experiment. We can including a crazy control treatment to compare what actually is the problem of social network. Here, the problem is network itself. It's not topology. It's not group size. It's a network connection itself.
In the independent, do they have the ability to get the money for, because there's no networks. So
yeah, no networks, but
they can't get the additional money, right?
They have the same payoff structure. So that means that they have $2 in engine. Then if a disaster happen, like if they stay, they lose everything.
Yeah.
Then if they evacuate it, if they $1, then you have $1 plus alpha. So that means even they do not connect, they know some other poor people join in the game to decide at the same time. So they actually earn the money as a player who make a decision, even if they do not connect it through the communication channel. Okay, the direct cause of the procrastination is the spreading of the false reassurance. So as I show in the animation, this graph shows the average fraction of each colored node over time in 40 node random regular network that's like animation when a disaster does strike. And the player sends safe signals more than danger signals from start to finish. And the spreading of safe signals overwhelms that of warnings over time, regardless of network size. So that is here the network size and network topology. Even when an informant knew that disaster would strike and correctly send warnings. And I've analyzed the data to examine why it happened. And there's some interesting idea comes up from the analysis, but let me share one interesting finding from the behavior analysis with survey. Before the game, each subject was asked with 5-level rating system about his or her preference regarding risk, cooperation, and trust. So you might know that people have a different preference on risk. Some people risk-taking, some people risk avoidance, and that might be affect, right, their behavior in the game. They're actually true only in the independent condition. So in the independent condition, for example, risk-seeking, if you are risk-seeking people, you do not evacuate, you stay. So here is a less than 1 means that they stay. And if they do more, then they evacuate. So risk-seeking people do not evacuate. That's right. So that means that because staying is high risk, high return option, so risking people take such action, and that's a significant result. But once they are in the network, the individual preference does not predict any behavior on that after controlling the signal exposure from the neighbor. So that means that critical communication actually can take over the individual agency. Whether or not you are the risk-averse, risk-taking people, more importantly, where you are located in network and how your neighbors communicate with you. All right, so in sum, this experiment shows that social networks can work for the status quo. So interpersonal communication reduced needless evacuation when there was no danger, but at the same time, it also reduced the necessary evacuation when there was a danger, even when a knowledgeable person in the group could correctly announce the existence of impending danger. And I finished, the one paper finished this moment. I really dissatisfied with my work because I'm interested in the social network, how social network works. Then this study showed how social network doesn't work. And then I really disappointed to my discipline. And actually, I would like to, because not only my expertise, that you don't care about my expertise, more likely that we could not live without networks now, right? So we are connected everywhere, especially through the online channel. And so that means, and also why we are connected if the social networks does not work when we need it, when we needed it. So that means this study shows that social networks does not spread of inconvenient truths. So here the warnings looks like meaningful information, right? Compared to the safe messages. Because safe message doesn't matter. As I told you, you don't necessarily. You don't need to do anything. You earn $2 if a disaster doesn't happen. The warnings is important, but also warnings is irritating. Because if you get the warnings, you have to pay $1 immediately. So that means people more careful to sharing the warnings. Actually, when I analyze the data, basically it looks like safe signals and warnings, danger signals, it's like same quality, but it's not. People share the safe signals with single contagion. So that if you see the one safe signals, you can easily to share the safe signal. But you are more cautious so that for the danger signals, you needed at least 2 or 3 warnings to share the warnings to others. That's why safe signals spread so fast compared to the warnings, and eventually that prevented for the necessary evacuation when a disaster strikes. So I tried to, how can social networks help people to make a decision in response to danger? I tried to the various different settings to find the network session is better than independent condition. Okay, for example, hey, as I told you, people could not see the evacuation, but maybe in some day technology allow us to show the actual behavior, for example, like a GPS signaling or something. So in the experiment, I let participants know the neighbor's evacuation. So really, if your neighbors evacuate, you see this node is disappear. Okay, doesn't work. It works, but it doesn't work to make the network session better than the control. And also, hey, maybe now we have a technology, we are always on. So that even during the evacuation, we can share the information, right? So that means that here is some dilemma happened. If you want to keep sending signals, you should stay. That might be prevent efficient coordination. So I allow them to, even after evacuation, they can communicate. It doesn't work. And also maybe here is a random regular network, there is no centralization. That might be not good in efficient communication. So I try to some like a regular random networks. So they have some center, they have periphery, a little bit, but it's not so. So then I eventually realized that where I might make a mistake, because social network can spread information and behavior, whether it is good or bad. When we need social networks information pathway, we might go nowhere. So that means that what is a good or bad is actually the people decision making. It's not social networks decide. And eventually I realized that if we develop some networks spreading the good information, might be also spread bad information too. You might have a different opinion. In that case, please try my experiment with me and how your system works or not. So I actually took a different way. So we might want to see the social networks as a mean of collective learnings. In this case, our appropriate research question is, how can social network help people learn from past failure in responding to danger and make a better decision in the future? So we might fail in the first place, but with social networks, we can make better decisions in the future. That's why we might have a social networks, about social network, and work together to that. I tested. Sorry, maybe that I talked too much. I changed my evacuation game for iterated version. Now players play the game multiple rounds with the same neighbors, same group of people, like this. And here, the game has 4 rounds. Sometimes a disaster happens, sometimes disaster does not happen. They make a decision, same decision, like a typical not. Then I tested with 3 conditions for group settings. Is that independent, same things, the crazy condition. The other thing, static networks, they play with the same network neighbors over time, over 4 rounds. Other one is the dynamic networks that they can choose their neighbors based on the past performance. So that after they play the game, they are informed about, hey, do you want to connect with this player? That this player like evacuated last round and sharing how long, like 10 seconds sharing warnings and 5 second warnings. Do you want to connect? Or sometimes I ask them to, oh, do you want to cut a tie with this player? Different these people because of this player's performance like this. So that means that in dynamic network condition, in the first place, this is artificial network, but over round, they emerge their network structure on their own. Okay, so last 3 or 4 rounds, it's a spontaneous network structure based on their decision making. Then how these group settings improve the collective intelligence over 4 rounds. So basically, whether they can make a better decision, especially in a disaster, when a disaster strikes. So here are the 3 group settings, and actually I decided only 4 disaster pattern. Of course, here is 4 round and 2, so that you quickly measure 16 patterns, but I only selected 4 patterns. But I actually 10 sessions each for each treatment condition. In total, I conduct the experiment with 2,700 people in 180 sessions, 180 networks. So let's see what's happening. So here's the main result of the experiment. Then the left figure is the no disaster. So if the no disaster, it's good with the networks from the start to end. Then when disaster strikes, here, again, 20%, unfortunately, in the first round. So most people fail to evacuate. But over round, they improve the performance, especially in the dynamic networks. So that's we expected, and that's good. So that means that we develop the collective intelligence through the network evolution. Is that? So that means we can develop the networks to facilitate collective information and spread the collective behavior with like a selective tie rewiring between the people. That's good. Can you go forward because of time? So the reason is that people can improve the way of sharing the information. So here is a round one and the very same result from the last experiment. Okay. Then here is a round four. Safe signal spread still in very fast minute. So still the safe signal spread faster, but after that, then the danger signals overwhelm, and after that mass evacuation happen at round four with dynamic networks. So that means the people change the way to send the signals. Actually, after the over four round, danger signals spread further and faster through the learnings or individual learning and collective learning. Okay, so because of the talk time, I a little bit shorter my rest of the part, but here is a point. How we could improve such a collective performance on sharing information and spreading behavior? 2 points. One is individual learning. So that means we might individually learn about the situation and make a better decision. Other things is network evolution. So that means that we might change the network topology to better spreading the true signals and true behavior. Okay, so here is a group structure perspective, very networky idea. Here is more cognitive idea. We can individually learn from the situation to make a better decision. But other idea is that maybe rather than the individual alone or the network structure alone, the integration of individuals and network structure might be a key consideration for collective learning. So on the top of the two mechanisms, I investigated the interaction effect between individual learning and network evolution by controlling each mechanism with statistical and experimental manipulation. So let me show how it is. So first of all, I analyzed people change their behavior individually. So that means that people share more warnings when they experience a disaster before. So once you experience more disaster, you're more keen to the warnings and share warnings, and also more easy to evacuate with some signals. So you can do like this type of statistical analysis. You can find like, hey, people share more warnings as experience with a disaster. But we cannot explain from the individual warnings why dynamic networks makes better than others, right? So actually, I statistically analyze people's responsiveness are not different between this static network and dynamic networks. So that means people are same, but they can share more true information and spread the true behavior with dynamic networks compared to static networks. So that means the network structure also have some effect, right, for the collective intelligence. So here is one of the network structure change over time, round 1 and round 4. Then I located the node at the same people. So this is the same people. Here is this guy and this guy. And the informant is same over 4 rounds. Okay. Then I show the node color indicated how long they send the safe signal or danger signals. Then here is a disaster session. So that means that red color indicated true signals and blue color is a wrong signal. Then in the round 1, even for the informant sending the warnings, nobody listens. Okay? They do not evacuate. But over round 4, people change their opinion, right? Then even the same level of the warnings, but people evacuate more. So that's the individual running. And also you can see there are a lot of connection compared to the round 1. So people more connected. That's good. The more communication channels. And also this node size indicated the in degree. So that means how many nodes incoming to them. So here the informant have a larger node size. So that means that many people accessing directly to the informant. That's good. So it looks like people develop their network, their own networks to facilitate true information through like a bottom-up way, right? This network structure, it looks good to spreading true information. So I tested if it is true. How is that? I recruited fresh participant, then play the game again with the evolved network. Okay, so that means that they are fresh player. There is no individual experience. Okay, so that means I control the individual experience, putting them to this network structure, and they play the application game in the first round. If the network structure have some effect for the collective intelligence, their performance should be better than this, and probably the same to this one. Right. Here's the result. No effect. Okay, so here is a lot of network connection and people accessing the informant directly, then the informant sending the warnings correctly, people don't listen if they do not experience with a disaster. Okay, so network structure actually have an effect, but conditional on the individual responsiveness. Okay, so if individuals does not have some have some responsiveness to share warnings in this case, network structure doesn't matter actually. That's why, for example, in my first experiments, independent function does sometimes happen. So here is the aggregated result again. You can see here the copy network. Then you can see no disaster station on the same level. So if you have some data from like observation study, then you might say, hey, if you compare to this, then hey, copy network is good as original network, but it's not. It's a disaster session, copy network level is the same as the original network at round 1. So here's my summary is that at least in this specific experience settings, there are some interaction effect between the individual learning and network evolution, but it's not equal. So basically the individual responsiveness is first, then the network effect is conditional on the individual responsiveness. Sometimes, like me, the social network analysis focusing on the structure, here is form. How form like change the behavior, like collective intelligence, spreading of the information. But we also needed to consider how individuals like change their response to the signals. Also, for this experiment, it's not only actually the individual, it's also the relationships with others. So over the round 4, people might improve the trust with the informant. But in the round 1, even if you connected the informant, you might not trust because they are strangers. So including that, I think that we might need to more consider about individual learning process within the network evolution. So for example, like, hey, this organizational structure is great, like a Google have a specific organizational structure, it looks great, but maybe it's not, the structure itself doesn't work if you just apply the structure to new people. We might need to consider how people evolve such a specific network structure through the interaction. Okay, that's my point, and I'm exploring such a things with like machine intelligence and AI technology. So how facilitating the collective learning process with partner recommendation, for example, to improve collective intelligence in an emergency. So it would be wonderful if I could exchange idea with you guys about these fascinating research topics, especially broadly the collective action in the humans and the machine. Okay, thank you. Yep. So questions?
Yeah, I have a question. Thank you for the talk.
Yeah.
I was curious. So it seems like at any given point, people are trying to figure out like which of the sources of information is correct or incorrect, and they have no kind of. Sometimes they have no way to tell that. And I was curious. What are your guesses about confidence? Because when people communicate information, they often communicate like, I'm 100% sure we have to run, or like, probably we have to run, or like, I'm sure everything is okay, don't worry. So I was curious, what are your guesses on if we introduce confidence as a part of communication process, whether it should improve or like.
So that means that okay. So that means that, so in other words, if we introduce some indicator of the confidence in addition to the signal, for example, hey, I think this situation is danger, like clicking a red button with some confidence level, like a 0 to 10. I'm sure like 10%, 10, or 5. Then, yeah, that additional information might help to spreading true signals, maybe. But at the same time, it's really difficult to choose such a complicated signal information in the emergency. For example, yeah, here is only 2 button things, but even in the real emergency situation, people cannot communicate such a longer sentence. Hey, here is.
Can be loudness of your voice, like run or like run.
Yes. Okay. Yeah. That's true. Yeah. For example, yes. So, yeah. For example, if you run, then in this case, people shouldn't click the button, right? So it's bit, yeah, maybe. So that means that should improve, but it's also, I don't think that my experiment does not include at all about that aspect too, because it's okay. They do not necessarily to communicate. And actually, I conducted this experiment not only to the online, but also in the classroom setting. Actually, it's a chance to join the experiment. Yeah.
I can tell you.
Yeah, if you like the.
So I think it's twice.
Yeah, I think for.
The first time I played it, I died. Like
Yeah, same. Even you study the spreading of false information. Yeah.
no, they're actually in danger. Maybe that like I didn't trust my classmates.
Yeah. Even it's no money, right? In the classroom setting. Yeah.
But talked about, how much trust somebody had, and then, in the, with the people that they're connected with. And then you talked about how, what was the first one? Like trust. And then I remember your graph, I don't know what the first one was. Risk. Right? It was like trust and risk. And I felt like those two were definitely things that I considered when I was pressing name. And I feel like though, like if I played it like more times, and then if I had the opportunity to like pick people that were like, hey, this person never, this person always got the money, I would definitely friend them and I would definitely trust them more.
Yeah.
And if they said red, I would definitely,
Yeah.
So, but it was interesting.
Yeah. So I think the dynamic network settings allow people to like evaluate the trust, right? So you can cut tie if you don't like the person. So then that helps. But again, it helps, but conditional on the individual learning. So if it's not, it's more like a dynamics important rather than the static set structure. So that's my point. Yeah.
So I'm wondering if trust is a factor here, because just by the design of the incentives, you shouldn't really need to trust an individual, right? Because if you believe everybody is, acting in their own self-interest, then the trust element should not be so big.
Yeah, but at the same time, you don't necessarily to trust people, but you should trust the information. So that means if you do not trust your neighbors, probably you do not trust the signal from them. Then you cannot decide the evacuation decision with signals. And actually, in this game, if you join the game, you really rely on the information from your neighbors. Then probably the people, especially here, they are strangers, right? With each other, and there is no trust basically. Maybe they trust with people in general, but they do not trust specifically that they are not friends. But they still rely on the signal, so they still have some trustness with them. Then overall, in the second part of the experiment, they develop actually the trust overall. So that's why they can share more warnings and they do evacuate. So that means that here is the evacuation, you needed to pay cost. So here the evacuation means paying cost immediately for the possible loss. What is exactly mean? Then if you do such a behavior, so paying money from you, you needed trust with others if you use the information with them. So I still think the trust issue also including this experiment, and the multi-round experiment help them to trust, to development of trust in this instrument. One-shot experiment is really hard to develop that. Yeah.
Yeah, thank you for the talk. Although I'm not from this background, but I think that the talk is very interesting and the result is fascinating. I have a quick question.
Yeah.
In all your experiments you showed,
Yeah.
it's only one person, one individual can get the truth.
Yeah.
But would you think about to add few more people
Mhm.
to know the truth?
Yeah. 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 So I think it's an obvious thing. If we increase the informant, probably the outcome should be better, right? Then the point is like, what is the efficient way to allocate the informant in the network? So in this, for example, like even for my first experiment here, is that I changed the node size, number of the group size, then giving one informant. So that means the fraction of informant change, right? Here is 1 over 10 are informed. Here is 1 over 60 are informed. They are totally different result. So should be the number of informants strong effect for this outcome. Then for this experiment, I don't want to explore the solution parameter space with the number of the informant, because if I increase the number from 2 or 3, then there is other variables is that the distribution of the informant. Do you understand? So that means that here is a, let's say, ring-lattice network. Should we put the informant separately or putting together? Okay, so this is an interesting question of the answer parameter. I think that's interesting, but I do not want to explode my experience. So that means, hey, 3 by 2 by 2 by something like that. So I do not want to explore the parameter space in the first experiment, but I think that's a very interesting question is what distribution of the informant works better to facilitating true information. Yeah.
Related to that, you're testing the effect of complex contagion.
Yeah.
And you might not need to, have a whole distribution of, selecting informants, but rather just, two conditions. One where you select 2 informants who receive the true message who were actually connected in that kind of ring lattice, right? So then, the transitivity allows for complex contagion to spread more easily, versus a condition where the 2 informants are separated.
Yes, is that true? So if I want to test the information sharing happen with complex contagion, I think maybe that I'm not sure that 2 informant settings might be enough, but yes, that's true. But maybe, how can I say? I already tested the complex contagion happen or not with this condition. Maybe I'm more interested in that more than that. So that means that maybe not only the complex contagion, but also how we can use the both contagion, the complex contagion, single contagion, to develop the collective intelligence. In that case, maybe for example, if the informant work together in the same time, they are inefficient sharing the safe signal, right? If the safe signal happen with a single contagion. Then the question is that what maybe in the middle point of the distribution, hey, we might be 3, then maybe here you work together or separate is 3, or maybe the middle point might be good. Or if I observe actually the ring-lattice network, they have a cluster. So that means that obviously here is the true people, here the wrong people. Then the wrong people could not get some of the group of people could not actually access the true information because your neighbors already clustered and sending the same signal, and nobody to the true danger signal could not penetrate to this structure. So even in that case, for example, like that's about just experiment design. So I don't say it's not impossible or it's not uninteresting, but just I choose do not explore the number of the informant for this case in the first experiment. But I think that's very interesting, especially the distribution of the informant if they have some multiple number. Yeah. Yeah.
Thank you so much.
Yeah.
I'm curious about the cost of saying
Mhm.
saying or
Mhm.
speculating. So I was wondering if changing the cost could have an impact.
Yeah.
The way that information is
Yep.
sent.
Yep.
Also because it seems to me that in real life there are different types of disasters which can impact the cost.
Yeah.
And that can change the network and the way that the communication can be done.
That's a good point, actually. And actually, as I told you, I try to find a way to network works. So one of the trial is to changing the evacuation cost. So here is $2 default and $1 evacuation cost. So in my trial, I kept $2 for default, but I changing the evacuation cost from 0 to 1.5. So 0, 0.5, and $1 is this, and 1.5. Evacuation, the change in evacuation cost does not affect the outcome at all, except for the evacuation cost equals 0. Okay, so if the evacuation cost equals 0, so there is no cost to evacuate, then actually the result is very similar to this gray line. No connection. And actually, if the evacuation cost is 0, then when the disaster does not strike, their decision making is like bad as independent condition. Okay, so it's crazy. So if the evacuation cost equals 0, people just randomly behave, right? Just following their individual inclination. If you think like a risk-averse people, you evacuate, no risk, no cost. Then if you are risk-taking people, you stay. Almost that's it. Then if I give, for example, 0.5, so it's very small evacuation cost, they still hesitate to evacuate. And so I tried one session with 0.1, so that means 10 cents evacuate, still. So that means the amount of cost itself is not so important. Just say you needed to pay something immediately to do something for possible. Here is a 50-50 chance of the danger. I think that's more important to the actual amount of the cost of the game, I think. Yeah.
I mean, just off of what you were saying, I was thinking that if the cost to stay was a lot more, was like $200.
Yeah.
Like, I was like, because I want to have more money versus
Show.
dollar a leave. I'm like, oh, be more.
Yeah, so that's true. For example, here is $2, it's too small. Maybe I will increase a $200, let's say. Then but evacuation costs $100.
Yeah, I mean, it's just like relative.
Yeah, of course, if you get $200, the evacuation cost $1, it may be different, but I'm not sure. I think that's important investigation. But my expectation is that if I increase the benefit of, say, like a $200, probably all these lines go up. So that means the independent condition people also like change, right? Then my point is that compared to the independent condition, how people in the networks behave better, and probably might be different, but I can imagine they just their default behavior change, go up or go down. Yeah.
Is there any association or you look into between the number of messages someone receives and the likelihood that they make a
Yeah, that's right.
correct
Yes.
decision? And then possibly related, do you have any guesses as to why people communicate when they don't have any, like in that?
Yeah, safe signals. Yeah. Yes. To answer your question, for example, I did some statistical analysis to see when they share the safe signals, the danger signals with exposure to neighbor signals. Basically, it's not only the number of signals, but also the duration, right? So signals, for example, where, hey, this two player keeps sending warnings for 14 seconds. It's a bit different. The two players keep sending just 5 seconds. So I actually controlling all the signal first, see how people change the behavior. So this is not the result, but I did. And actually the safe signal, people share the safe signals only with 0 or 1 safe signals on average, controlling for others. But dangerous signals needed 2 or more, 2.5 on average, 2.5 warnings on average to make a decision. So that's a different. Then to answer your question, why people share the safe messages, sometimes without any information. It's hard to question. This study is not examining why, but actually I told you that I did this experiment a lot with classroom settings and also some demo to the company. And the result always almost same, even for some sophisticated CEO, blah, blah. But then I ask them why, for example, you did like this, right? In the classroom I could do. Then there are various reasons. One is no news is good news heuristics. So that means, hey, I could not get any information. So that should be okay. Then I should share the safe messages with neighbors. Okay, that's one thing. The other thing is actually, yeah, this is just a game, this is economic game, but people really worry about the situation in the crisis. So that means that some people are shaking actually during the game to evacuate or not. Really. So such a stressful condition, people want to chat. Okay. Then when people want to chat, danger signals is meaningful messages might change people's behavior, right? Paying a cost. So if you want to connect with someone, then people choose to send safe messages. Do you understand? So that means if I click the blue button, then I see the blue button from my neighbor, it looks like, hey, I will still there. Then people stop shaking or something like that. So I'm not sure, but actually some people say like such an anxiety and stressful situation in the game. And people said, when I communicate in some way, like clicking a safe button, then I felt better in the game. So that means that here we usually think about, especially analyze the data, we think about like information, we see information as utilitarian way. So that means we communicate, like we exchange information to get the benefit, or do you understand? So that means that more like a cost benefit things. But actually the people communicate more social way. That's no meaningful sometimes. So content itself, it's not important. Right? Communication itself gives a meaning to them. Then here is same messages, right? For example, like here, if you hear some warnings now, then probably we face with each other, they're a little bit laughing. Hey, something happened. We do that, right? Same things happen in that. Then, especially in this very standard situation, there's no way to correct such an initial spreading of false safe signals. I think that's the two main reasons. Other reasons, third reason, I think it's less likely to happen, but third reason is that economic reason, is that staying is the most beneficial outcome if the disaster does not happen, right? So maybe some very egocentric person might be do some bet. Hey, here's 50-50. I will bet staying because I can get more. Okay, do you understand? Then I let other people do the same things, because if nothing happen, I can earn the maximum if other people stay. Do you understand? So, and also it might be happen in the real world too. So that means here is uncertainty, 50-50, we don't know. But some risk-taking person might be try to get involved others to maximize their own benefit. Yeah.
Because that's the maximum payoff.
That's maximum payoff when the disaster does.
If you decided to stay.
There's no disaster. Yeah. But interestingly, if you calculate it, expected utility, you can calculate easily the 50-50, then get the balance. Actually, the evacuation is more than stay. So if you are economically rational and calculate it for the whole run, you should evacuate. Rationality is bounded, especially here is the point is that emergency situation is that we need to pay the cost now to prevent always uncertain, even for like a 70% of the chance, 80% of the chance, still 20% of the chance, you might not need to pay the cost. And that situation is really hard. I think that's the cause of such a disaster situation with the networks. And networks, so famously in the real disaster, the panics rarely happen, surprisingly. More likely to happen like a false reassurance. People do not like take a proactionation action. Even they, for example, hey, almost flooding, but people do not leave their house. So that's famously the status quo bias. And for example, even in the 9/11, in the building, people didn't have a panic. People coordinate well, working very socially, and some people actually went back to their office to take a key. Then they got actually the crash, something like that. So people try to do something regularly in the irregular timing, and social networks actually enhance such a bias. So I think the social network enhance any individual bias, and especially in this case, it's a status quo bias that prevented to spreading of correct information. I think that's the high-level answer to you. And people typically try to be the status quo. Then there's various reasons, no news or good news heuristics, or maybe people might want more chatting in the stressful condition. Okay. Yeah.
One question. So your final slide, you said this is the co-involvement between individual learning and network structure that matters. But on the other hand, there has been a lot of people that study network structures and they try to propose some change of network structures to make, for example, the organization perform better. For example, some network consultants, they will study the networks of people in an organization and say, hey, maybe the research department should communicate more with the marketing department so that your performance could be better. So, but in your case, what you show is that it's probably not going to work because, you know, the networks, what they are right now because of the functions or because of the individual perceptions about what's going on in this group. So how should I integrate those two ideas together?
Actually, my work tried to integrate two ideas. One is very structurist idea. So that here is a network structure itself has something, okay, so effect, so very social network where. The other thing, more sociological idea is a cultural perspective, human agency. So each individual develop from the interaction with like others, like a society. The here is actually there the two things happen. It's a bit different, like not equally. So basically the here, in this case, actually human agency in the cultural evolution is first. Then the second is network evolution. But still, network structure, dynamic networks works. That means the network structure itself has an effect. But the point is, I think, again, I told you, like dynamics matters rather than the static structure. So that means that here, hey, maybe some specific structure works, for example, some organization. But at the same time, people there needed to develop on their own to have the structure. Okay, so the process is more important rather than the structure itself. So I think here is a good structure. Hey, these companies work well. Then it's really hard to, hey, I'm putting the different people, a different company, then putting a structure, probably doesn't work. The clear reason is that they have no relationship with actual participant. Hey, now this person is a more boss, they have more centralized, I don't know, centralized, decentralized, which works. But maybe some specific structure works for some social context, maybe straight to information or like a work organization. But at the same time, maybe if this study can be generalized to the organization context, maybe we should consider about the dynamical process to have the structure. Okay, not just giving a structure. How people can develop such a structure over time through their own experience. I think that's important to involving individual learning in this network evolution process. Okay. All right, yeah.
I mean, I don't know if we have time, but I was curious, can you show that little bit of the animation of the diffusion process? I mean, if you could go to it, just because I don't know if there was a person that hit danger,
Yeah.
but I wasn't sure if they were connected to the original person. So I was kind of wondering if there are any cases, or have you looked into cases where within the experiment, there are people that are erroneously or like false positive, saying danger, and how that influences. I think,
yes, that's right. Yeah, some people, yes,
they're connected to the person over there, and so like 4 of the evacuations aren't even related to the true data.
Yeah, for example, this guy.
Yeah,
yes, true.
that person I don't believe is connected to the important.
Yeah, yes, that's right. So this person sending warnings without any information. That's true. The same thing happened for the safe signals, right?
Sure.
Most of the original information spreader of the safe signals have no information, right? No truth. So yes, that's true. So that means that both cases happen, like sending warnings without any information, sending safe signal without information. That happened. But in my data, people more sending safe signals rather than dangerous signals. So that's more likely to happen. Without information, the safe people share the safe signals rather than dangerous signals. Still, people hesitate to dangerous signals.
Right.
Without information.
I guess I'm just curious because I mean, in this situation, there was a disaster, strike, and people evacuated. But you could think of a scenario where there's like a false panic.
Yeah, false panic. Yes, that's right. So that's actually happens sometimes in my data, but it's not significantly affect overall result. I mean, but that's true. It's true. So both way happen. So this is a human subject experiment. So it's great. It's like not clean, very caustic situation, but there is some social order exist.
I have just some crazy case to share related to your conclusions. I'm Russian, half Ukrainian, and what I've observed, so when I was in Russia back after 2014, when the first case of war with Ukraine happened, interesting thing happened is that there's been an increase in immigration from Russia and from Ukraine of Jewish people. And the increase is like officially documented, like the statistic was just growing up and up until like recent years, of course. And there was like the saying that, oh, if something bad is going to happen, then Jewish people will be the first ones who will like actually able to get rid of that. And I was just curious, could it be possible, like it's just crazy idea that somehow their structure evolved, like structure of social interaction somehow evolved so that facilitate this
it's possible. And also
signal. And actually, like I left Russia right before the war because of my Jewish friends who were like, Roman,
you should
now it's gonna be like so
obviously that's true. So for example, if you do not have a connection with them, you might steal the Russia, right? So first of all, but in the observation study, it's really hard to distinguish between two. So that means that Jewish people have historically needed to move, right? So that means that culturally, they already have some tendency to evacuate with very low information of the warnings, maybe. But at the same time, they might be develop their own organization structure to sharing such an information, then that might be benefit to you. There, two things happen, I think. Typically, people focusing on the structure, if you analyze the data structure way, but I believe we cannot discern both from the observation study, and we needed to consider both. And it might be related, interesting interaction happen, and experiment might supplement in that way because we can control, like my experiment does that.
This would also kind of just what you're generally kind of point to. There's some literature on strategies that bots use to manipulate social groups. They find individuals that, in a sense, since the network has evolved, like a Twitter network has evolved, where people are waiting, like how reliable or whatever that this person is. They try to get that person to share the initial. Need that person to share the. So I mean, I find that it's we see that happening in the real.
And also this is maybe good reason.
why does that happen?
Yeah, and interestingly, like now it's about the design, not to only the simply targeting the people, maybe putting in the group of people, then maybe develop the relationship with other before spreading.
I mean, especially with the in the 2020 election cycle, or 2016 election cycle, there's a lot of bots that were creating social movements around like Black Lives Matter.
Yeah.
And they weren't from here. They're they're
I know that.
they created these events.
Yeah.
And they create a community that they then were able to.
Yeah, that's right. So they started to creating a structure and trust with others, then spread, right? Yeah, they might be already know that before I conduct the experiment, maybe. Yeah. Anyway, okay, thank you very much.
Thank you.
Thank you.